Now we're going to talk about Therac-25 in detail because it's a notorious example of a notable system failure in history, and I think you most probably have discussed this in your software engineering courses as well. Most probably, I don't know. In a German physicist, Wilhelm Röntgen, in 1895, he invented the X-ray. Today, 50 to 60% of cancer patients are treated with radiation, and linear accelerators are used for this purpose, and electron beams are used for shallow tumors, and X-ray beams are used for reaching deeper tumors within the body. And Therac-25 linear accelerator was notoriously unreliable, even not unusual for system malfunction 40 times a day. It's normal. I mean, the people were expecting this, like you press the button and it's not working, you press it again or something like this. It has many bugs in it. This particular case is an important example about how the safety of a system relies solely upon the quality of its embedded software causing harm directly to humans. In 20-month period between June 1985 and January 1983, massive overdoses to 6 patients has been done, resulting in 3 deaths. This is why it's really important. Although 1987 may seem like distant past, I mean, it's history, but the entire story has been truly researched and documented. This makes this Therac-25 case particularly interesting because of its detail. It is detailed documentation and investigation. AECL, which was a Canadian company, and CGR, which was a French company, cooperatively built 2 linear accelerators in 70s, named as Therac-6 and Therac-20. Therac-25 is the modernization of these old versions, with computers especially integrated in it, with ease of operation for the operators because it has some better user-friendly interface. But be careful. Now here in this version, safety features were built into hardware in Therac-25. After Therac-20, CGR left the business, and AECL, the Canadian partner, continued for the next generation Therac-25 project. Software is now an integral part of the system, and it is incapable of operating without the computer. They designed it like this, replacing the hardware safety features of Therac-20 with software safety features in the new version. Reusing the code of Therac-6 and Therac-20 was also efficient for them, saving time and money, and they also relied on the approach that tried and true software is more reliable than fresh code, like reinventing or rediscovering the United States, America again. No need for this. I mean, we're using tried and true software. We cannot say that they're, directly wrong, because this is what we're told in some of the textbooks as well. They say this. This has also been suggested. And first Therac-25 was developed or constructed in 1983, and 11 systems has been put to use in Canada and United States consecutively. What kind of device is this? It has a large machine room. A large machine located in its own room. It has lots of shielding walls, ceilings, and protective floor from radiation. It has a TV camera, microphone, and speaker for communication between the technician and the patient as well. Look, it's a huge device, in fact, with lots of components, not only computer part. These are some serious events that happened. In Marietta, Georgia, in June 1985, a 61-year-old breast cancer patient which was treated by radiation to collarbone. She complained that she had been burned. Okay, then hospital physicists contacted AECL and reported the case. Maybe there is a bug in system. Can you please check this? The company engineers replied that it is not possible. But however, overdose crippled the patient. They understand that she had received the overdose, and the physicist estimates that like almost 75 to 100 times too large overdosing had been conducted for her, and the patient sued the company and the hospital in October 1985. So note this, the company has been sued in October 1985. And then in Hamilton, Ontario, in July 1985, a 40-year-old woman this time who's seeking treatment for cervical cancer. The operator started the treatment and machine shut down itself after 5 seconds with an error message displaying shows that no delivery of radiation to patient yet. So the operator typed P for proceeding again, where the system shut down again with the same error message. Recall, it was not unusual for the machine to malfunction several dozen times a day. It's a common occurrence, and the operator pressed P 3 more times, always getting the same result. Treatment suspend mode, treatment suspend mode. Then operator went into the room and patient complained that she has been burned, and again this party reported to the company. They contacted the company again, and when she returned for further treatment 3 days later, it has been discovered that she was overdosed for 65 to 85 times more than what has been planned. Unfortunately, he died in November. He died next month, a few months later, in November 1985. Then, when someone gets killed, the first AECL investigation started from July to September 1985 period. They sent an engineer to investigate. He has been unable to reproduce the overdose, but they uncovered design problems about a microswitch, and the company introduced hardware and software fixes to that particular microswitch problem. Now, another incident in December 1985 in Yakima, Washington. Now, another woman receiving radiation therapy series developed a strange reddening on her hip this time, several parallel stripes notably. And the staff tries to determine the cause. Why did this happen? And maybe the accelerator's blocking trace, which have already been discarded. Maybe this was causing these things. So they suspected radiation overdose as well, and contacted the company by both letter and phone that time. The company described that neither Therac-25 nor the operator error could have produced the described damage. It's impossible. They explained in a 2 technical page report that why it is impossible for Therac-25 to produce overdose in this sense. And it also claims that no similar accidents have been reported as well. You only say this. I mean, we never received such a complaint before. The patient, fortunately, let's say, lived with mild disability. In March 1968, in Tyler Hospital, Texas, a male patient receiving the 9th series of a radiation treatment for a cancerous tumor on his back. This time the operator entered the treatment data into computer. She notices that she typed X, which is used for X-ray, instead of E. She should type E, in fact, for electron beam. This is a quite common mistake because X-ray treatments are more common. Being an experienced operator, she fixes her mistake by changing X to E on the screen and moving the cursor back to ready position again. The system says beam ready. She types B, beam on, and after a few seconds the system gets shut down. Malfunction 54. Okay, treatment pause, a low priority problem which is happening which is happening over and over again during the day. Those monitor shows that patient only received 6 units of dose instead of required 2002. So operator pushes P again to proceed, or types P again to proceed. Normally, there is a video camera and intercommunication facility for establishing communication in the 2 adjoint rooms. We know this from the design of the room, remember? And however, none were functional at that time. Another mistake on the other one. And the patient received 8 prior treatments. So he's an experienced patient. He was experienced, so he immediately realizes that something wrong is going on. And he was unaware of the overdose. He was aware of the overdose, which he later then explained that it was been like someone poured hot coffee on his back, or someone applied electric shock to his back. He explained the situation like this. When he tries to get up, system delivered a second dose, hitting him on the arm. Look, this is like a horror movie, frankly. And he starts pounding on the door, warning the operator. He received 80 to 120 times overdose. He lost his bodily functions, and he is dead after 5 months. It's very, very, sad event. After the Texas incident, the hospital in Texas shut down its Therac-25 system and notified the EACL. 2 engineers has been sent to examine the system. They told the physicians that it was impossible for Therac-25 to overdose a patient, and suggested that the patient must have received electroshock due to a leakage in the hospital electric system. Hospital checked its electrical system and no faults found. Then they double-checked Therac-25 calibration again. They find nothing and nothing else to do. They put Therac-25 back into operation again. Why did they put that device back into operation again? Because they have no choice. There are lots of cancer patients waiting for therapy in line, and you cannot shut down a system without without proper evidence, or without enough evidence, right? I mean, you cannot say that, okay, someone gets overdosed, but I'm closing down the system, because lots of people are seeking treatment as well. They are waiting in line. And in Tyler, Texas, again, in April 1986, replay of a prior accident with the same technician. This time the intercommunication working, and the operator could hear the patient screaming, but she couldn't do anything after a massive dose of radiation to the brain, killing the patient within 3 weeks. Hospital immediately shut off Therac-25 again and contacted the company directly. This time, the hospital staff, another one, okay, in 1987, a second patient here burned with the same of December 1985 accident. 4 days after the treatment, patient's skin revealed a series of parallel red stripes. This time, hospital staff matched the 2 cases and perked, where unfortunately the patient died 3 months later. Finally, in February 1987, Therac-25 finally declared defective by FDA, Food and Drug Administration, losing its FDA approval, and in order to get the approval back, AACL must show how they will make the system safe. 5 months later, and after 5 revisions, the company demonstrated a corrective action plan, including a variety of hardware interlocks to prevent machine from delivering the overdose or activating the beam when the turntable was not in. Okay, why were this happening? The software errors, and I'm sure you remember this from software engineering and operating system courses, most probably. What is a race condition? Let's just remember this. Where 2 or more tasks sharing a variable. These type of design and the bugs that happen because of this are extremely difficult to identify and extremely difficult to fix. Usually because the tasks do not interfere with each other and nothing goes wrong at all. Since they do not interfere, so you think that everything is normal. Only in very rare conditions this happen, and it can result in a catastrophe. Now let's see. The first problem in the design was the command screen error. Like this is how they designed this. This is what you select. For example, you type here X for X-ray, and you type here E for electron beam. Electron beam. You remember this one was deeper tumors, and this one was for shallow lesions, shallow cancers they were using for this. And you write the dose here. Here you write the dosing, and when you just imagine that you have some errors like keys to move the cursor, and then you move your cursor here, tick, 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 then you move your cursor here on the right bottom side of the screen. It means that what you type here is valid and ready. It means that you're done setting here. Okay, this is how it works. When you write this and put this one here, I mean bring your cursor here, then these magnets start rotating and taking position due to your inputs here. Okay, it's just arranging itself, let's say the gun points. Okay, the problem is when the operator returns here after this has been started and corrects the X to E here, or just shifts the number here, maybe it was a mistake, and then brings the cursor here back again, it is unaware of this change. Okay, look how catastrophic it is. This is why some of the people get burned. I mean, because in fact, this is a very, very interesting condition. Only experienced operators make this happen. If you're a very experienced operator, you can type very fast and make this thing. But if you're a beginner operator or not very experienced, you will do it slow. Okay, click by click and checking again. In the meantime, and it will find out that the cursor is not here and start from all over the positioning, for example. But if the user is an expert user, she's very good at her job, it means that it can miss this quick update. So it's one of the problems. And the second one is the gun positioning error. The thing is, when your say laser guns or electron guns are not in place, it uses a counter. Okay, unless the counter is 0, pressing proceed button will not work. Okay, it's just counting here, counting unless this one gets in position. When this is in position, it will overwrite here 0 value. Look at this. I'm pushing here, but since this one is not 0 here, it means that they're out of position, the guns. So no matter how much I put here, press the button set, it will not give you the beam because it's out of position. But when it's 0, it is in position, it will overwrite this value to 0 and stop counting. And when you proceed here, it will proceed. However, what is the problem here? As you notice, look, this is counting from 0 to 255. There is a possibility that it is passing from 0 during counting. This possibility, when you press the set button, and it is passing from 0 at this time, although the guns are out of position, it will give you the beam. So again, look, this is nightmare. I mean, it's horrible. That's another error. So when we look at the postmortem here, end analysis, the overall analysis here, AECL focused on identifying and fixing software bugs here, like making patches. In fact, most accidents are system accidents, and the entire system was broken here, not just the software, the design. There was a serious flaw in design here, at least 2 flaws that has been uncovered after the investigation. Look, remember this good engineering principle that we discussed at the start of this session. What was that? A system should be designed so that no single point of failure will lead to a catastrophe. A good engineered design should be like this. And Therac-25 designers ignored this fundamental engineering principle, resulting in many deaths. And the lack of hardware and software devices to detect and report overdoses was another flaw. And there should be some mechanisms to detect this overdose, and the system should shut down itself immediately. Instead of doing this hardware locks or doing this safety procedure, the designers left it up to patients to report it when they had received overdoses, just like giving testing to beta gamers. They should have considered a mechanism for detecting overdose themselves. Now, it is obvious that very difficult to find software bugs in programs with multiple tasks running at the same time and interacting through shared variables. We should avoid designs like this as best as possible. Because it can cause catastrophe. The second point here is, rule of thumb. The software design needs to be as simple as possible, not full of patches. And the third one is the code must be reasonably documented at the time it is written, not later, not to fulfill some standards or something, not like a burden. The code must be reasonably documented at the time it is written so that it will be much more efficient. And keep in mind that the reuse does not always increase the quality of the final product. Earlier codes resulted in no problems because there were hardware interlocks to stop the overdoses. In fact, the codes were faulty that time again. Just safety mechanisms were working so well that it was shading the faulty codes, hiding them. And we should address that the tragedy has been multiplied because AECL didn't fully communicate with their customers as well. Just remember that they are telling them that overdosing is impossible. Okay, our device cannot do this. Even though they had already been sued by the first harmed patient in Georgia. Remember? In 1985 in Georgia, they had been sued by the patient. But they didn't care. Now, let's take a look at the moral responsibility of Therac-25 team. So, can they be held morally responsible about what is going on? Of course, they are legally responsible. You understand the distinction, right? They're legally responsible. They need to, pay the lawsuit costs. They need to pay for the debts, whatever. They should give some money for this legally. But morally, are they responsible for this? This is an important question. For moral responsibility, two conditions must hold. The first one is causal condition. The actions or inactions of the agent must have caused harm. Okay, this is obvious. But a second step is required for moral responsibility as well. Mental condition. The actions or inactions of the agent must have been intended or willed by the agent. So intention is important here. Did they do this willingly, intendedly, or what else? Now be careful. Pause this video and think about this, okay? Just pause this video now and think about this. The first one absolutely holds for this particular case, but what about the second one? Does mental condition hold here? Of course, they didn't do this intently. No engineer or no project manager wants to kill people like this, right? This is crazy. No one will do this. But not engineers or not project managers, but philosophers extend the second one with carelessness, recklessness, and negligence as well, with the intention. So being careless, reckless, or negligence can be comparatively or equally responsible in these situations. Be careful, okay? So we can say that the Therac-25 team are morally responsible as well in the deaths of these people. It's a very high burden. I mean, it's more than the legal burden here. Moral responsibility is something more than that. So we can conclude that Therac-25 team is morally responsible for the death.